Hi, so today I would like to talk about application of second order, which is mechanical vibrations. So this is this is our team members. Um, so for the mechanical vibrations, the general equation will be my double prime plus by prime plus ky equal to ft, whereas m here is mass, b here is damping coefficient, and K here is spring constant, and the last one Ft is external force or external vibration. There are four types of vibration. Number one is undamped vibration. The equation will be my double prime plus ky equal to 0. In undamped vibration, there is no damping. As I mentioned earlier, damping is B. So when there is no damping, B is equal to 0. So at the middle here, there is no B. Second one, there is no vibration involved. Means that the Ft at the back here is equal to 0, and the equation here will be a homogeneous equation because we can see that it is equal to 0. Second one is damped free vibration. The equation will be my double prime plus by prime plus ky equal to 0. In damped free vibration, there is no vibration involved, so it means that the Ft at the back here is equal to 0. So when it is equal to 0, automatically it is a homogeneous equation. Third one is undamped force vibration. The equation will be my double prime plus ky equal to ft. So there is no damping involved in undamped forced vibration. So b at the middle here, there is no b at the middle here because b is equal to 0. And looking at the equation here, we know that this is a non-homogeneous equation because it is equal to something, equal to a function. So the last one is damped force vibration. The equation will be my double prime plus by prime plus ky equal to ft. From the equation here, we know that all elements involved, and the equation will be a non-homogeneous equation since that it is equal to something or a function. So from me, thank you.
Alright, this is the first example. The first example is about damped force vibration. As the question said that the response of an of a damped system to constant force is governed by this equation. So, if damped force vibration, therefore, it has all the element, which is the coefficient of d2y over dt squared is usually 1, which is the mass. The coefficient of dy over dt is b. B is the damped coefficient. The coefficient of y is 6, which is refers to spring constant. And 18 especially refers to Ft, which is the external damped force. And the question also given us the initial condition where y 0 equal to 0 and y prime 0 equal to 0. That means from homogeneous equation we have to differentiate. So we have two homogeneous equations to find the value of a and b. The question asks us to compute the displacement yt and what happened when t equal to infinity. Yt here is equal to yh, which is homogeneous equation, plus yp. So first step we have to find the homogeneous equation. How? Let's go. So first step we have to find the roots from characteristic equation. What is characteristic equation? Characteristic equation is from am square plus bm plus c equal to 0, which is it is quadratic equation. So the value of a, b, and c we can get from here, which is 1 equal to a, b equal to 8, and c equal to 6. So we substitute here and we got this equation, and we got two value of n, which is m1 negative 4 plus 10, and m2 equal to negative 4 minus 10. And then the second step we substitute this m1 and m2 into this homogeneous equation, this m1 and m2, so that we get this equation where a and b is not determined yet. How to determine? The equation gives us the initial condition where y0 equal to 0. This means this is referred to the value of t, and this is y. So when y equal to 0, t is equal to 0, and then exponential e power of 0, we will get 1. This also we get 1. Therefore, we get the 0 equal to a plus b. So this is our first equation. And then we have to find y prime h. Y prime h is get from, we differentiate the homogeneous equation from here by using product rule. After we have this equation, we use the initial condition where y prime 0 equal to 0. So we substitute when y equal to 0. So when this is t equal to 0, we know that exponential e 0 is equal to 1. This is equal to 1. This is equal to 1. And this is equal to 1. So we only have this equation times 1 plus 1 here plus 1 plus negative 4 minus 10b plus 1, this one. And then we simplify and we get 4 minus 10a plus 4 plus 10b equal to 2. This is equation 2. So we can see that we have two simultaneous equations. We can solve it and we get a equal to negative 0.31c, while b equal to 0.31c. And then we substitute split a and b into this homogeneous equation. Therefore, we get this equation y t equal to negative 0.316 exponential of negative 4 plus 10t plus 0.316 exponential of negative 4 minus 10t. Okay. After that, we have to determine yp, where the ft, we know that ft equal to 18. That means this is polynomial. This is polynomial. Therefore, general equation for polynomial is xr cn xn plus cn minus 1 xn minus 1 until c naught, until the equation plus c naught x naught. So as we can see here, there is no x power anything behind this. So we substitute x when r equal to 0. So x0 times c naught x naught. So x naught, we got x power 0 is equal to 1. So therefore we get c naught only. And then we get ypt equal to c naught. So after that we have to compare yp, this yp, we have to compare with yh. Is there any similar term? No. This is constant and this is exponential t. So no similar term. So we can continue to find the differentiate y prime equal to, we differentiate constant, this is constant, so equal to 0. Differentiate 0 equal to 0. Therefore we get yp equal to, this equation, y prime prime and y prime, we substitute back into d2y over dt plus 8 dy over dt plus 6y equal to 18, right? So this is yp. We have to substitute. So this is 0 and plus 8 times 0 equal to 0. 6 times y is c naught. So we get here yp equal to 6 c naught. And by comparing yp equal to 18, both left hand side and right hand side is constant. So we can directly get the c naught equal to 3. And then c naught equal to 3, we substitute back into this equation and we get ypt equal to 18. Since we get yh and yp, therefore we can get the equation of yt equal to yh plus yp. And then we will get this equation. This is from yh and this is yt. When t is equal to infinity, that means this is y infinity, this is also y infinity, and then we substitute infinity, t equal to infinity and t equal to infinity, we get exponential of negative infinity and exponential of negative infinity. That means is this show that 0.316 over infinity. We know that any number over infinity equal to 0. Therefore, here we get 0 and here we get 0. And then the remaining is 18. So the displacement when t equal to infinity, the displacement of y is 18.
For example 18, a 3 kg object is attached to spring and it stretches the spring 392 mm by itself. There is no damping in the system and a forcing function ft equal to 10 cos 5t is acting on the system. The object is initially displaced 20 cm downward from its equilibrium position and given an initial velocity of 10 cm per second upward. From the word there is no damping in the system, we can get the general solution of the mechanical vibration. We need to write down the governing equation of the above spring system and find the displacement at any time. Firstly, we need to standardize the unit system from millimeter to meter and extract information from the equation. We got m equal to 3 kg, L equal to 0.392. From the words no damping, we use my double prime plus ky equal to ft, while ft is equal to 10 cos 5t. Then we find the k by using the equation mg over L and get 75. Then we find the initial condition. Therefore, the governing equation is y double prime plus 75y equal to 10 cos 5t. Step 1, we need to determine the YH. From the 3m squared plus 75, we factorize and get m value, which is positive minus 5i. From the m value, we knew that this is a complex number. Then we use YH equal to a cos beta t plus b sin beta t. We replace the beta with 5 and get YH equal to a cos 5t plus b sin 5t. Then we need to determine the YP. Since the ft is 10 cos 5t, which is trigonometry, we need to use YP equal to t to the power of r c sin beta t plus dot minus t cos beta t. We try to replace the r with 0 and compare with YH. From the comparison, we can see that there is a simultaneous which cannot use the equation. Then we use r equal to 1. Then we compare again and we get a different equation. There is no similar term in the equation. Then we differentiate yp to get yp prime and differentiate again to get yp double prime. After we get yp prime and yp double prime, in step 3 we substitute yp prime and yp double prime into the first equation. From the long equation, we compare and get c equal to 1 over 3 while d is equal to 0. Hence, yp is equal to 1 over 3 t sin 5t. In step 4, we need to find yt, which is yp is plus yh. We get y equal to 1 over 3 plus sin 5t plus a cos 5t plus b sin 5t. A and b is constant, so we need to find it. In step 5, we use the initial condition to determine the constants. When we replace the yt with 0.2 and t equal to 0, we manage to get a equal to 1 over 5. Then we differentiate yt to get y prime t. To replace the y prime t with the initial condition, we replace y prime t with negative 0.1 and t equal to 0 and manage to get b equal to negative 1 over 50. Substitute the constant into the equation and we get the final answer, which is y equal to 1 over 5 cos 5t minus 1 over 50 sin 5t plus 1 over 3 t sin 5t.